is f negative 1 of x. Now remember, this symbol means inverse. So there are a few different ways to do this. Specifically with the inverse, we switch our x and y's. And so that's what I'm going to do now. I'm going to come over here. The f of x is the same thing as y. And so the first way I'll do this problem is by doing the algebra way, which is switching x and y, and then you solve for the y. So to get the y by itself, the first step I would need to do here is get rid of this division of 3. The opposite of division by 3 is multiplying by 3. So when I do this, I can cancel those two out. And I now have 3x equals y minus 1. And finally, to get y by itself, I need to add 1 to both sides. Adding 1 will remove that from there. And so I'm left with 3x plus 1 equals y. And at this stage, you can substitute in f negative 1 of x equals 3x plus 1. Now, one thing we need to do with this is we always need to check for domain restrictions. What do I mean by that? Is we would go to the original graph and see if we need to do anything with the domain range. So we would go over here and check out the graph. And the graph was x minus 1 over 3. And here, really in pre-cal, what they'll try to do to confuse you is they'll have a problem that's different where we would have a domain restriction. Now this one, as we see the original, the domains of the original was all reals. And that should be a double R. And the range was the same thing. It went forever up, forever down, forever left, forever right. Now this one, we would just switch the domain and range. So the domain and range would switch. So in this case, it would end up being exactly the same because this all reals would become this one, and this all reals would come from here. But there's many problems in pre-AP pre-cal where you're tested where it won't be that way. For example, if it gave us original equation of f of x equals x squared, if we were to graph that, you would see that this would need to have a domain restriction. Let me just kind of mark this off and see there's a different problem here. If I went to the graph of this one, you see how we have a domain of all reals, but the range is from 0 to infinity. What would happen is here, though the domain is all reals and the range are values from 0 to infinity, what would happen is when we'd find the inverse, which in this case, the inverse, we would have to either write this way. We'd have the square root of x, but we would have to restrict. So technically speaking, if you just flip-flop that, you put this in the calculator, you would get a domain. Let me just show you. Why am I trying to talk it through? If I just solved it and got the square root of x like this, you'll see real quick that it's not the opposite because it does go from 0 to infinity for the domain, which looks good because it's so far being switched. This one's domain would go from 0 to infinity. But then when we go to find the range, it should be all reals. But I look in the graph and you'll see it's not all reals. It's not going down forever. It's going also from 0 to infinity. So this is where you would just switch your domain and range when you want to find the inverse, or you would have to restrict this one. If we wanted to say that the range is from 0 to infinity this way, we need to come up here and restrict. And that's what I wanted to point out. Although you didn't have to do in this problem, if you see the word restrict, what you would do is you would just change it to where they match. Or when you flip-flop the domain, this one becomes the range, and this one's domain and range would also flip-flop.